Thank you. Hello, everyone. My name is Gladys Rama, and I'm the editorial director here at Converge 360. And I am so pleased to be moderating our first session, as well as welcoming you today to our Cloud Data Protection 101 Summit, brought to you by Rubrik. The editorial staff of Virtualization and Cloud Review and RedmondMag.com have worked together to bring you the best independent expert on this topic for this event. So we really hope you enjoy it. Before we start today's event with these two great sessions, we do have a couple of announcements. First, we wanted to let you know that this event is being recorded and will be available for future viewing. You'll receive an email when the replay is available, generally within the next few days, so keep an eye out for that link. Second, each of today's two sessions will be followed by a 5 to 10 minute Q&A. So please be sure to put your questions into the Q&A area of your console as they come up, so we can get them answered for you. And third, at the end of today's session, the second session, we will be giving away a Rad Mission 1 electric hybrid bike, but you have to be present to win, so please be sure to stay on for the entire event. And finally, we do have a demo link from our sponsor, Rubrik, that's available on the console right now, so please download and check that out. It's because of Rubrik underwriting this content that we can bring you the summit. So we thank them for sponsoring today's summit and supporting the community. And we ask you to please check out those resources from Rubrik so we can bring you more events like this in the future. Now, on to the first session of today's summit, Cloud Data Security Basics. This session features Joey Biantoni. He's the principal consultant at Danny Cherry and Associates Consulting. Joey is recognized as a VMware vExpert and a Microsoft Data Platform MVP, and he has over 20 years of experience working in both Fortune 500 and smaller firms. Joey's worked extensively on database platforms and cloud technologies and has specific expertise in performance tuning, infrastructure, and disaster recovery. And real quickly, I want to plug his column on RedmondMag.com called Joey on SQL Server, where, as you can expect, he talks all things SQL Server. So check that out if you haven't already. It's a great resource. Joey, the floor is yours.
Thank you very much, Gladys, and hello and welcome, everyone. It's a wonderful spring day where I'm sitting in actually Indianapolis, Indiana. I usually am in Philadelphia, but I'm here for some car racing this weekend. And we're going to talk about data security in this session and cloud data security specifically. This is a complicated topic for a lot of organizations. I run into all manner of organizations. As you can imagine, as a consultant working with the technology stack we do, cloud and data platform, we just see a lot of different types of customers, whether it be government agencies, big enterprise businesses, smaller organizations who really just want to protect their data and make sure they don't get breached. But one of the keys that I find across all organizations, but it gets worse in larger orgs, is understanding your data. So what data are you keeping? How are you keeping that data? How is that data encrypted? This is a really important thing because the amount of resources you have to focus on security and in turn data security are finite, right? You only have a limited amount of resources. You can't you can encrypt everything, but that's called ransomware. So I digress. You can't really encrypt all the things. You want to understand where your sensitive data is, how you can isolate that, but how you can also still make it usable. And as you move into the cloud, you want to understand what lives in your cloud and what has access, who has access to your cloud. So what data is there? How's it structured? What's the network look like in terms of what can talk to what? What's the security protocols that you have in place for the various control planes and data planes? And we'll talk a little bit more about that in depth, but it's something I'm always concerned about. Who has access to your cloud and kind of how do they have access? One of the things we've been working towards at DCAC is just trying to generally improve our security posture. We don't actually have a ton of data because we're a consulting firm and we basically consume software as a service offering. But we do have our own cloud environments where we have demos and we have like domain controllers and things like that. So we've been trying to improve our organizational posture around how people access the cloud. We've had multi-factor authentication on as long as we could, but we've recently started adding some additional things like conditional access and privileged identity management. I want to talk through all of those things. The next point we're going to talk about in this session is, how private are your endpoints? This is something that I wish I could stop talking about, but it seems like whenever you do a search on S3 data breach, there's something that comes up about somebody who's using Amazon storage service and has a data breach. And to not simply isolate Amazon, a famous organization in the United States who runs football just had a publicly announced data breach. Yes, that's the NFL, using Azure, which I was kind of more impressed with because it's much more obvious in Azure when you're making something completely public. Amazon does warn you, but you can kind of accidentally do it. And I understand why it happens in Amazon a little bit more. But anyway, so endpoint protection is something we're really going to touch on and talk about as you use more platform as a service offerings, how you may want to look at some third-party tools or even tools in your cloud to support that. And then finally, we're going to talk about understanding the services that your organization is using and what their security vulnerabilities are, and maybe even consider limiting the services that your organization is using, because and this is a compromise between like rapid development and taking advantage of all the things the cloud can do for you, and then also managing your security posture. Because I know just looking at the areas of service I deal with on all the time, which is Azure SQL and Azure networking, and there are all these like little nuanced differences in the way security for various, not necessarily the core database security components, but the way like ancillary components work in terms of security. And I mainly know all of those for Azure, and I don't even know all of those. So trying to stay on top of all those little nuances and in all the different services can kind of drive you crazy and potentially increase your risk. So it's always just something to keep in mind. So what data do you have? This is a kind of a boring organizational topic. We're about to hopefully start on a project to help a customer do this. But data governance is not really an IT function. It's an organizational function that involves both business users, IT leadership, maybe data leadership if you had it. Like ideally, your organization has a data governance team and you kind of understand this. In a small organization, in a very small organization, it might just be where do we keep all our data? We use X for a payroll system. We use Salesforce for CRM. We use QuickBooks for accounting, and we know that's where all our data is. In the case of, for example, my very small company that's even smaller than PCAC, I use QuickBooks. That's where all my data is. It's either in QuickBooks, in my email, or my bank account. But as you grow and as you scale and as you get more people and as you build more complex systems, as you interact with third parties, understanding what data you have is super, super complicated. However, this does allow you to support modern security protocols for data access. One of these things is attribute-based access control, and I was working with recently a data lake vendor, and they were supporting the Department of Defense in the United States. And there some public material they were putting out was around how by having good tagging and some automation around their data governance process, they could allocate access control based not just on users and roles, but based on the attributes of the document, which is kind of, I think, where we're headed probably in the next decade as to how we grant access to various things in our environment. I think I hear attribute-based role control a lot more. And I think that, or attribute-based access control, not role control, a lot more. And I think it's something that's definitely trending upwards. And it makes a lot of sense because as your number of data sources increases, like if you think about the number of data sources that the Department of Defense has, it's probably over 50,000, if not 100,000, if not more. having to have someone or some group of people manually assign those roles, or even an automated role assignment, is still going to probably not be granular enough, and is typically going to end up, in my experience, with over-granting of data. So that's kind of the start of the data governance aspect. So what do we do? How do we build a catalog? This is kind of the center of all data governance efforts. And Microsoft, to their credit, has put a lot of investment here in a service called Purview. I don't know that there's anything similar on Amazon yet, but there are other third parties that have data catalog services. The one I was working with the other week, I can't remember the name of it right now, but they specifically work with Databricks to provide kind of data cataloging and security services. And one of the things that I think is promising on some of these services is they will interrogate your data sources. That does require you know what all of your data sources are, which is sometimes a challenge. However, once you know what those data sources are, and you can point the catalog service at your various data sources, it will interrogate them, and it will do some intelligence based on things like column names, some data analysis to kind of make determinations about how your data should be classified in terms of this is financial data, this data has GDPR potential, this data is PII. That helps you build better and better intelligence. Ideally, in an ideal world, but this never happens, you would want to have those things done as you're building systems. But a lot of times you're buying a third-party system from somewhere else, and they don't specify what the properties of their columns are. So you have to either reverse engineer their database yourself, or their file system, or et cetera. But the tooling is getting better and has more intelligence. So that's a positive of where things are going forward. But the first step to even building a catalog is to understand where all of your data lives, what it is, and how sensitive that data is, and who accesses it. That's something else that I've seen some stuff with Purview recently, where they're working on heading down that path. Because this is, as you can imagine, if you're trying to do this even with a tool, if you're trying to do this manually, you're having to make a lot of judgment calls. You're not just, if you're a database professional or you're a system administrator and you're looking at data that's related to your business, you don't necessarily know what it means. You can hazard a guess, but you're kind of always having to escalate this up to a business team. And I think this kind of helps you understand how data governance itself is a multifaceted process, but it's really important in terms of security, because we can't just encrypt everything or secure everything at the same degree. So having a good catalog lets you know. The other thing, too, about a catalog, and I've read this in some data breach reports, is if you know you're breached and you have everything cataloged, when it comes to things like GDPR fines, you can say, this was the data that got breached, this is how it was accessed, it didn't actually contain any GDPR data, so your fine will either be lower or maybe not even. So it's important to understand all this, and it's kind of a key part of everything we're talking about here. And I know it's boring and not technical and organizational, but it is really a thing. The other reason here is, like I said, you need to know your data, know thy data. This lets you know where your data should be encrypted or masked. My favorite encryption story is we once built database encryption for a customer, so one person couldn't see another person's salary. The company was that small, and they had us build encryption for them. But it's not just encryption. We also, a lot of various data systems have the option for masking data. So if you're not familiar with masking, it's, for example, if you only need somebody to see the last four of a credit card or the last four digits of a social security number in the U.S., that's data masking. That's something that's typically not done for administrators, but it can be done in a number of database systems and data systems. Encryption is hard, and we're going to talk a little bit more about various flavors of encryption. Encryption at rest is just something that I kind of expect everyone to have at this point. But realistically, encryption at rest doesn't buy you any protection from somebody who has access to that data. So actual in data stored encryption is very hard. It's easier than it used to be. We have better solutions for it. We have better chips, so we can do it and still have systems that perform well. However, it's still not easy. It's still probably going to require engineering time from your application. You also probably can't encrypt the third-party app because they'd have to change their code. But your sensitive fields should be locked down, at least in terms of permission, and ideally encrypted. And this is going to apply whether or not you have a data lake, a database, a file share, any of those things. The basic concepts are the same. You have some better tools and some commercial type systems like databases and data lakes, but at the same time, even if you're just putting this on a file share, you can get pretty granular with control if you design it correctly. Beyond a catalog, I think it's really helpful to understand the workloads that your organization has deployed to the cloud. This depends on how your organization is going to migrate. I talk about all sorts of cloud migration strategies. I know I've written a few articles in Redmond on it because I've gotten to execute a bunch of these migrations myself, and I think some have gone really well, some have gone not so well, and the differences are usually like testing. But a lot of times an organization is moving to a cloud because they have an expiring contract at either a data center or a colo, or there's some financial incentive to get into the cloud at a given time. And the migration kind of happens in what I like to call a big bang format, where everything gets shoved over at once. There's not a whole lot of care taken in the systems that are migrated. It's just we're taking everything that's in data center A and moving it into AWS US East 1A, and then we'll figure it out. It's really helpful if you can build as you're doing this cloud deployment. If you can build something. A metadata management system to help you understand. One of the things all the cloud supports, and anytime you hear a cloud architect talk like me, I'm going to preach about tagging. You can tag the heck out of your resources with all sorts of things like cost centers, environment, test dev production, system, find error department. All those things really help you better understand your cloud. And the other part of this, that if you're approaching it from an IT security aspect, that I think is something that's worth looking at, especially in a larger organization where you can potentially have some shadow IT efforts, is some of the tools from cloud vendors that will kind of sit on your network and look for other cloud services that might be in use that maybe your IT organization is not aware of. That's not really a problem in a small org because everybody's going to know mostly what everybody else is doing, but as you get into to orgs where VPs have a great deal of spending authority, a lot of times what will happen is maybe IT is not getting a system that meets their needs fast enough, and the R&D department will go up and spin up their own set of cloud resources. And having something to monitor that is pretty important too, because a lot of what we're going to talk about later about security policies and things like that, if you're not actively managing those accounts, you're not going to be able to enforce policies and things like that. Understand the services your organizations use. I talked about this a little earlier. We'll talk through it more later in the deck, but it's really helpful to understand how and why you're using security or services. Don't just use Amazon Kubernetes service because your CIO decided that using Kubernetes was a really good idea. You want to use you want careful thought about how you deploy services. Especially, there's kind of a variety of PaaS, platform as a service offerings that I like to call infrastructure-ish. It's a hard word to make up on the fly. But you have services, and two good examples, and they're database related because I live in databases a lot. Amazon RDS and Azure SQL Managed Instance. Both those services are kind of very infrastructure heavy. You have to know how to make the network work on both of them. You're responsible for storage and things like that. So there's a lot of security stuff that can kind of go wrong there if you really don't understand those services. There are other services that you just kind of consume and you don't really think about. So it's important, especially if you're in a larger organization, that kind of have your cloud architects do an eval of services and maybe bless services for usage. because that way you can better stay on top of, what the services are and what the risk and the endpoints that are there and those sorts of things. So cloud security. This is a really crude slide that I made the other day. I've had a long couple of weeks. I did 3 weeks of training in the end of April, beginning of May. So getting these slides this week on time was an accomplishment. But in general, we have the way we access the cloud is we're coming from the internet, and this could be a direct connection depending on your network connection. But you can also have users connecting through the internet. You typically have some sort of firewall in front of your cloud control plane, which isn't exactly accurate because it is a public endpoint. But in a lot of cases, the way you'll secure that is you'll limit the IP addresses that can access that, or they'll have to use something like privileged identity management to access your control plane. And if you're not familiar with the control plane, if you haven't used the cloud, this is portal.azure.com, console.aws.com, Google Cloud's console. This is where you manage and deploy resources. And this can be a website, but realistically, it's an API. Because anything you're doing on that website is hitting the API. Any PowerShell or CLI scripts that you write against that is hitting the API. And everything's effectively the API. The other part of that I like to talk to is the data plane. And this can be a database, a data lake, a NoSQL database. This is where your organization's data is. And this is also typically firewalled off. I have a line there between data plane and control plane. And that line is kind of, it's connected, but it's not inherently connected. So one of the things that comes up a lot is, you might have cloud administrators who don't have access to your data, and that's fine because your data is locked down within a database. So they can manage the cloud stuff, but they can't log in and grab data. And especially if you're using a services provider, that may very well be your model. But this is just a rough idea of what a basic cloud security control looks like. So control plane access. Like I said, this is where you build and configure things in the cloud. And there are a lot of reasons why it's really important to secure this. As you can imagine, if somebody impersonates, let's say, a global administrator in your Azure account, or the subscription administrator, or the root user in your Amazon account, that account now has the ability to delete all of your resources, or even better yet, spin up new ones that cost you a lot of money to, say, mine Bitcoin, although maybe this week that might not be as popular. But it's really important to have good security around this. You want to have multi-factor authentication just as a first step. We have, just to give you some ideas of how we have our stuff configured, we have conditional access policies where you have to auth with multi-factor authentication just to get access to that control plane. In fact, I typically, not on this computer, but I typically use a UV key as my multi-factor authentication. So I have to have a PIN and a physical key to get in. We don't force that for everyone. I haven't broken everybody into doing that yet. I think it's a good approach. It's really secure. But you do have the ability to do that. Not everybody needs to have access to your cloud. And one of the things you want to be on the lookout here for too is, as you build applications, because one of the things that happens with cloud applications is you build applications out, you give those applications identities in your cloud identity management solution, and then those identities have the ability to do something. The cloud solutions are getting better about not requiring secrets with those, but there are still some types of applications that do require storing secrets in the application. This is one of those places you want to make sure you don't have developers that are publishing secrets to GitHub. There are also services that can look for secrets in GitHub, so you can make sure nobody did that. But because that can happen, and it has happened where there are people mining for secrets on GitHub, and they went and spun up various cloud resources, much to the chagrin of whoever was paying the bill, to the tune of like $35,000, $50,000. Those are just some of the things you need to be aware of. Like I say, not everyone needs to have access. Think about who had access to your vCenter environment if you were on VMware on-prem. That's mainly the group of people that needs to have it. I think you're probably extending it a little more to developers. But beyond that, not everybody needs to have access. You should grant permissions very narrowly. We're going to talk about scope on the next slide, but you typically have a scope of where you grant permissions, and you don't want that scope to commonly be at the account level in AWS or the subscription level in Azure, because those permissions cascade down. That's the way role-based access control works. So I'm subscription owner of DCAC sub, so therefore I can do anything where there's not an explicit deny saying I can't. So you want to narrow those to specific resources or maybe groups of resources. And as always, you want to use the principle of least privileges. Only grant what you need to do. And I will pat myself on the back because this morning I was creating, this is not really a cloud solution, although it technically was in the cloud, but I was on a Windows server that was not joined to a domain, and I had to grant a user access to stop and start a specific service. And I did go onto Docs and look up the way to do that through some very obscure NNC commands. So I will pat myself on the back for not just granting that user admin like I really wanted to do. So treat your cloud the same way. The permissions are very explicit. There are a lot of built-in roles that work pretty well. Sometimes those built-in roles may over-grant permissions, so understand that. But in general, scope narrowly and use principle of least privileges. So scopes, I know we just talked about this, but this is the way generally cloud RBAC works, just in general, and this isn't universal, but it's mostly. You have owner, contributor, and reader. And those three roles are at all the layers of your cloud. And owner can do anything and grant permissions. Contributor can simply do anything, and then reader can only read. Amazon has similar, I'm speaking kind of to Azure there, but Amazon has kind of similar functionality in their RBAC. It's not that different. And everything kind of derives from that model. Where you grant those permissions affects the scope, or is the scope. So like I was just saying with subscription, if you grant it the subscription or the account level, the account owner can do everything in that account or subscription if you're in Azure. You typically want to really limit who has that subscription owner kind of level permissions to simply your administrative users, and those should have extra special care about how they authenticate and how they get in. Like we have, I mentioned we have the multi-factor. I also have privileged identity management in place. So if I want to be admin Joey, I have to do a special process that if we wanted to, could have a second person to approve it. This allows us to have much tighter security. So understanding those scopes and narrowing those scopes. For an Azure example, resource groups are amazing. So I kind of just typically will grant access to a resource group to the users who need it, and then delegate from there. They can do what they need in the resource group. I can monitor that resource group. But the other aspect of this too, there's two other things I want to touch on in the slide. One is I wouldn't just stuff all your things into one subscription or account, especially in a larger organization. You want to set up different subscriptions or accounts for different groups in your org, because that's going to be a billing and security boundary. But you also want to understand what the multi-subscription or account paradigm looks like. In Azure, there's a thing called management groups. I think in Amazon there's something similar, but it's a little bit harder to configure. Management groups let you manage multiple subscriptions from one place. What that means is you can apply things like policy. And if you're not familiar with cloud policy, It's very similar to like Active Directory policy. It just applies to cloud resources. So if you say in our subscription, we don't want to have any resources deployed to West US because we don't really like LA and we're East Coast people. You can specify that in your cloud policy assignment. You can specify the types of resources, and these are two really basic examples. These get very granular, and there are a lot of them that are tied into audit standards and various federal government regulations. But you can deploy policy like across those environments so that you're enforcing things universally. Just to give you a real basic example, in DCAC, in order to create an Azure resource group, you have to have the following two tags: client name and then date created. And that's the policy we have because it makes for a good demo and it helps us keep our subscription a little bit cleaner. But that's just a real basic example of how you would assign a policy. And that policy is assigned at our management group level because we have 5 different subscriptions. Endpoint data management, S3 data breaches, that is all. If you're ever bored or you don't trust what I'm saying, go to your favorite news search engine. Mine is news.google.com. I'm sure there are others. And search S3 in the words data breach. It slowed down a little probably over the last 6 months, but it used to be there would be like one a week. I'd say now it's maybe 1 or 2 a month. I think in the very early days of Amazon S3, which is Amazon's object-based storage, a lot of folks deployed stuff there without really thinking about security at all. And what that meant was you had a publicly available file on the internet. Because the reason why we even have the option to use public S3 or public Azure Blob Storage accounts is if you want a very basic static website, you could stick an HTML file in S3, and because that HTML file is on the internet, you can connect to it and you have a very basic website. However, I think when a lot of people started using Amazon, they didn't really think about security. They were just like, oh, this is really cool. And in the early days, Amazon didn't have as good of a security posture and warnings about this. They do now. It's much harder to do. I will admit, though, I still did it last year because I was troubleshooting something for a customer in AWS, and I was only using sample data. So I was only using actually Microsoft sample data. And I couldn't get private networking to work between the service that I was using in S3, and the error message wasn't helpful, and I was just in a hurry and wanted to make it work. So I did. I made my S3 bucket public, and anybody could have captured the AdventureWorks database from my S3 bucket. But this is a common problem for a lot of orgs because they've had data breaches. Like I mentioned, the NFL left and Azure one open, which to me that frustrates me a little bit more because having used both, and I will fully qualify this by saying, I do have relationships with Microsoft as being an MVP. They do give me Azure credits. But in terms of the way storage, endpoint configuration, and network management works, in my opinion, professional opinion as a user, it's way easier to configure secure networking on the Azure side than the AWS side, at least from the user interface, not code necessarily. And the NFL still had a data breach from an Azure Blob Storage, so it happens. Many cloud services do have public endpoints, and this is where it gets really important to know your services. Like Azure SQL Database has a public endpoint by default. You can ping your Azure SQL database name, and it will resolve, or maybe not ping, but if you telnet or testnet connection at port 1433, you'll get your Azure SQL database name, and the connection will authentic, or at least go through. There is a firewall in place as well, so you have to be aware of that firewall. You also have the ability to not make that public. So you really need to understand all the options for your services and what they are. And this is where I start to talk about, you want to, especially from a security architect aspect, understand what those services are, because that's something that's really important, and they're different, and they're all just different enough that it's really frustrating. You can't write one single script. So as I mentioned, you have to be proactive in managing this. This isn't something that This isn't something that's super easy to do. And the big thing is I can run a scan this morning. I can enable like various security tools, and I can say, hey, we're secure. We don't have anything that's public that we don't have locked down behind a firewall, and we're all good. And then a developer could accidentally expose sensitive data 5 minutes after I did that. So I think that's something that's kind of important to understand. And this is something where you really want to look at a third-party tool. I mean, the cloud vendors themselves have tools in the space that I think do an okay job, but you can have their third-party tools that effectively act like pen testing that are kind of constantly probing your IP ranges and things like that, so that they're going to know if you hit something, if you leave something open accidentally, and you'll get alerted, and you can isolate it faster. Because having to try to do this manually, especially in a larger environment, is going to be impossible, and it just puts you at risk. So I did some research in building this slide, and it was accurate. There are 18 different ways to deploy a container on AWS. I was really kind of blown away by that number. I was a little taken aback, to be honest. That's 18 different ways you can screw up your security. I'm sure some of them are easier than others to screw up. There are also at least 15 native ways to run a database on Azure, and this was not counting VMs. I counted all the various just database services on Azure, and there are 15 of them. Each of these services uses a slightly different security model. Managed Instance and SQL Database have different networking security models. Cosmos DB kind of has its own firewall thing as well. There are a number of nuanced differences between each of these services. Likewise, some of those container services on Amazon may be public, some of them may be private. And these minor differences seem like they may not matter that much, but if you don't understand those nuanced differences and you do leave a port open or you expose something to the internet, that's going to be a real problem for you, because in mainly your organization, but this is where I like to really say you want to have a blessed set of services that you're going to use. And a lot of times development teams don't like that. As a DBA, I've got a lot of experience telling development teams no. So I kind of take advantage of that. I've done a lot of jobs, but my last real job was being an architect. Before I was consulting, was being an architect at Comcast Cable. And this was a lot of what I did was bless various systems. So we'd test them, we'd rely on security experts, and we'd say, this is the approved list of things you can do. And if a developer came to us and made a good case for a new tool set that they wanted to use and wasn't on our approved list, we would expedite it to get it through. But we wanted to make sure we had a pretty good understanding of how it was going to work, how it was going to fit into our network and security models, and just what it did and how it worked. We were fortunate at our scale at Comcast that I could just call an engineer. I'd call the vendor, and usually I could get a pretty senior engineer on the phone pretty quickly, and we could kind of talk through that. But if you're nervous about a cloud service, especially if it's something like beyond VMs, talk to your cloud vendor, talk to your sales rep, and try to get a briefing on it. Reading the docs is good, but sometimes reading the docs can be a little bit confusing if you don't have a really great understanding of just what the whole model is. Our sponsor for this session is a backup vendor, and I did not include this slide because of them. I just want to mention that. Backups, if you read anything I write, backups are super, super important. Understand what your backup and, more importantly, your restore options are for data storage. And this applies to all manner of data storage. I live and die in databases, and database backups are super important, and I'll talk about that in the next bullet. But you want to understand how anything you have in an object store is backed up. If you have data in a data lake, how's that backed up? Basically, you should live in paranoia of a ransomware attack or somebody hijacking your cloud account. And what would happen if somebody who really didn't like your company did that? and what are the horrible things they can do. And there's a reason why restore is bolded there. So you want to understand, what your disaster recovery scenario is. This is another question to ask of any of those PaaS services you want to use, right? Because if you're using a database as a service offering, what's the restore look like? What's the restore timeline? Can I get a disaster recovery database as a secondary? And most of them you can. But that's something that you really want to understand. The other point of this is where, as a cloud architect, you balance a lot of conflicting things because you're always balancing availability, performance, security, and cost. And backups add a lot of cost. One of the things I kind of stick to, and this is specifically something I talk about with SQL Server, but I also talk about it generally speaking with databases, if you can do it this way. I recommend to my clients that they don't back up their database servers. I recommend, in SQL Server, you have the ability to back up your databases directly to Azure Storage. I tell my clients they should back up their databases that way, but they shouldn't actually back up the servers. And the reason for this is it's faster. I can deploy a new SQL Server in Azure in about 6 minutes, and then I can just start restoring their databases. If they have some kind of complex configuration, like an availability group or a cluster or something like that, we can save the configuration off for that in PowerShell, and we can get that back in place in even seconds. So just understand that. Understand how long you need to keep your backups, because that's another dimension of that expense, and if they need to be in more than one region. The other thing I want to mention here is there are storage tiers, and generally speaking, the hot and cool tiers aren't super different in price, but the archival tiers are really, really cheap until you need to restore. So archival tiers in your cloud storage are really good for when the government says you need to keep your backups for 20 years or whatever. I worked for a really terrible medical device company who did really awful things, and we had to keep all of our backups forever. And archive storage would have been great for that because we never restored those backups. But if you actually have to do a restore, it's pretty bad. So just keep that in mind. So I kind of consolidated this session into 10 tips, and I'll still have a summary slide at the end to wrap up. But if you have any questions, put them in now. I'll be happy to answer because we'll be wrapping up here in a couple minutes. Understand what data you keep, for how long, and why. And this doesn't just apply to backups, right? That applies to your general data keeping. Keeping data is expensive. People have to manage it. You have to secure it. Is there a business value in your organization keeping that data? Encrypt your sensitive data and limit access to the keys, and make sure you store those keys someplace securely. By the way, the clouds are really great places to securely store your keys. They do have really good key vault solutions. Control who and can and how people access your cloud control plane. So you want to lock them into having really good security there. This is my mandatory MFA plug. I always will plug MFA. Everybody's always trying to hack you. You should use MFA wherever you can. You should also probably use a password manager if you're not. If you're using the same password multiple places, stop it. One password really did change my life. I kind of don't know any of my passwords anymore. And you can also use FIDO2, which I've really kind of taken a liking to. This lets you do passwordless authentication. And you should use cloud policy and scope it accordingly. And cloud policy is probably its own talk. Maybe I can do that another time. Watch out for those public endpoints. If you can use private networking for a cloud service, do it, because then you don't have to worry about the endpoints. You should always monitor for those public endpoints and then alert on it. And then backup, and test those backups. One of the cool things about the cloud, as DBAs, we always preach that we needed to have the ability to test our backups or test restoring our backups. And the storage teams would always be like, we don't really have the compute capacity. Well, guess what? You're in the cloud now. You can spin up a VM for a couple of hours. You can provision. I actually did this once. 492 terabytes of storage in like 30 seconds. So there's no excuse not to be able to test your backups and really just understand what your backup solutions are for various cloud services that you're using. And then finally, archive storage is cheap, but expensive if you need to restore it. So just to wrap up in summary, secure your control plane, know your data, get that data catalog, talk to folks about data governance. It's not the most sexy topic, but it will really help you out. Watch out for those open storage buckets or containers, and then any other endpoints in your environment. With that, I see we've had some interesting questions, so let's get started with that.
Great. Thank you so much, Joey. Yes, and we have a couple of great questions here from our audience. To get started, here's something that you touched on earlier, but it'd be good to get a little bit in depth. One audience member asks, are there guidelines regarding masking versus encrypting data?
That's a really great question, and I can take that kind of from a Microsoft perspective, but it's probably going to apply to other vendors, at least in SQL Server land and Azure SQL land. Masking, it only works for it doesn't work for administrators, first of all. So you can't, like, if I'm a DBA, I'll always be able to see the unmasked data. And that's just because of the way Microsoft has chosen to implement that feature. But it's the way most vendors, I think Oracle kind of does the same thing, where they apply that at the presentation layer, but the data is stored in the database in its native format. Encryption, on the other hand, is different. Encryption is designed so that the database administrator can't see the data. So even if I'm effectively root in that database or admin, or choose your flavor of person who can do anything, that account will only see encrypted data. And there's been some advancements made in this in recent years. So masking's first, typically, I always kind of like to say masking's for when your application doesn't really have the security you need, and it's a quick fix that you can send back masked data. Encryption requires probably some more effort at the application level.
Right. Great distinction. Here's another audience question for you. How should you assign and scope cloud roles?
That's a really good question, and it's got a really long answer. I think you should assign and scope. It depends on the size of your organization, and that's the first. It depends. So, in a really large organization, what you're going to end up doing is like giving subscriptions or accounts to either department or organization. So like finance might have their own, HR might have their own. And then within those teams, you'll kind of let them manage down the line. And this is kind of where policy comes in, because you want to kind of have some overarching policy management. I've worked with some large organizations though, where they let their dev teams have their own subscriptions and then just run with them, which is a little scary to me. And the irony of that is I've been teaching cost management to said organizations, so maybe that's not working so well for them. Yeah, it quickly becomes kind of a big thing, but it's going to typically will end up going a little bit beyond IT, but maybe not a lot beyond IT, because anything that's like a data asset, you're probably going to be assigning those permissions from within some data plane, whether that be a data lake or a database. And those users don't have to directly connect to the cloud and access the control plane. So it's typically an IT and development thing. So you kind of want to start to think about it that way and think about it from there. The analogy is like, I always like to kind of get back to is who would have had access to the data center, which is a really old school way of thinking about it. But it's a good starting point, and then you can kind of work down from there as to who needs access.
Right. Got a question for you about MFA. You're a big advocate for it, but one audience member asks, what is required for MFA on cloud accounts?
So in my experience, in Azure, it's built in. You do have to have certain tiers for it. In my experience with AWS, I've had to use a third party. I think they do have a native solution now, but almost all my clients that have used AWS have used Okta or Duo in conjunction with it. So just typically, you need a service, some service level that will do that for you. for Azure, I mostly use my Authenticator app to authenticate into my clients as my third party. Like I mentioned, DCAC now has, I did enable us to support using a UB key, or if I had Windows, I could use Windows Hello as well.
Right. That kind of ties into a question that I personally have, Joey, but so these cloud platforms, they have their native tools to manage security backup. At what point is it time to stop looking at the native tools and look at a third-party solution?
That's a good question. So, like, I can definitely say on the backup side, I think there's a lot of good solutions. There's a lot of good reasons for that. A lot of the third-party backup solutions might better enable you to move out of a single cloud if you had to. And if you're in a multi-cloud world, especially with the security tools too, you can manage from one cloud to another. And both vendors have tools, and I should include Google more, but I just didn't get to work with them as much. I know AWS and Azure both have services where you can manage resources in the other cloud from whether it be the AWS console or the Azure portal. You can manage services in the other cloud by effectively installing an agent on those resources. But yeah, especially if you're multi-cloud, I think you want to look at third party. One of the things I find some of the security recommendations in the native tools lead you down the path of is recommending you buy value-added services from the cloud vendor, which, that's kind of an obvious thing. But I think that's something you want to be on the lookout for. And I honestly, from a backup perspective, Rubrik makes a great tool, and there are a few other vendors in the space that are good. From a security perspective, I don't necessarily have a recommendation on a third-party tool. I haven't evaluated that many of them.
Right. Let's see here. We have another audience question, kind of similar to that. What are some of the encryption options that are available in the public cloud?
Lots. So one of the things I mentioned, just about everything. So I think after Sarbanes-Oxley happened, public companies started having to encrypt everything at rest, which is cool. But what encryption at rest protects you from is somebody taking a hard drive out of a server and then mounting it into another server and then reading the contents of it. With the way security is at AWS and Azure data centers and GCP, nobody's going to be able to do that anyway. The other thing it protects you from is somebody stopping a service and grabbing your VM's files. Likewise, in the cloud, that's probably not going to happen anyway. But they encrypt everything at rest by default, so you have met that audit checkbox. So understand encryption at rest doesn't really buy you a whole lot, but it does meet the audit checkbox, which does get the auditor off your back. Encrypting within your data sources is a little bit harder because you're typically going to have to work. There's really two ways you can do this. Whatever your data store is, whether it be if you're using Databricks for a data lake, you're using Oracle or SQL Server for a database, you're going to have to understand the fields that need to be encrypted and understand how that database or data store encrypts them. The other alternative to that, which is less fun, is if you're writing custom applications, you can encrypt the data in your application and send the data, whatever your data store is, encrypted information, and then unencrypt it. I would not typically recommend that. It's honestly, that's kind of the way Always Encrypted works in SQL Server, but you're using libraries that Microsoft built, and it's a little bit easier to do than. There's a saying on Twitter: "Never roll your own crypto." Never roll your own crypto.
Great. Let's see here. I think
cryptography, not currency.
It's a good distinction to make, Joey. Thank you. And I think that's all the time we have now for audience questions. Although if you think of a question for Joey later on that you didn't have time to, that didn't occur to you, please just throw it into the console and we'll make sure that we get them to him. Thanks for the great presentation, Joey. Let's see here. Just stay tuned. We're going to go on a quick break. And we'll be back after, at the top of the hour, to start our second session of the day, Cloud Architecture and Cloud Data Security, Top Do's and Don'ts. In the meantime, check out that demo link on your console provided by Rubrik. Hang in there and we'll be right back.
Thanks, Justin. Hi, everyone. Welcome to the second session of today's online summit, Cloud Protection 101, which was organized by the hardworking folks at Virtualization and Cloud Review and sponsored by Rubrik, the Zero Trust data management company. I'm John K. Waters, Editor-in-Chief in the Converge 360 group of 1105 Media, and I'll be your moderator for our second information-packed session. But before we get started, just a couple of quick reminders. Each of today's sessions is being recorded for later access. Keep an eye out for an email with a link to that recording. It'll be coming your way within the next few days. Also, this session will be followed by a 5 to 10 minute Q&A. You can type your questions into the Q&A box at any time. Please feel free to add your questions as they occur to you throughout the summit. We'll do our very best to get to all of them. You might have noticed that our sponsor Rubrik has provided some extra resources that can be found on the right-hand side of your screen. Please take a moment to check those out. And at the end of this session, one lucky attendee will be receiving a Rad Mission 1 electric hybrid bike, a super cool Metro bike from Rad Powered Bikes optimized for urban riding. But you got to be here to win, so stick with us. Now let's get started with our second session, Cloud Architecture and Cloud Data Security, Top Do's and Don'ts. Joey D'Antoni is back with us for this session, for those of you who missed the first session, and that's too bad for you. Mr. D'Antoni is Principal Consultant at Denny Cherry and Associates Consulting, with more than a decade of IT experience with Fortune 500 companies, as well as expert certifications from Microsoft and VMware. He is a well-known thought leader in cross-platform IT. He has worked extensively on database platforms and cloud technologies, and he has a high level of expertise in performance tuning, infrastructure, and data recovery. You are in for another great session. Take it away, Joey.
Thanks, Sean. Hi, everyone, and welcome back, or welcome to those of you who weren't here. This is a cool talk to put together, because one of the things about giving two talks in a rapid time like this is I want to make sure they're pretty different. So in that last talk, I think we did kind of an overview of cloud data security, and we kind of touched on all things data. This session, I think, is going to be more generally around physical cloud architecture to an extent, and then best practices. There are good patterns for cloud and data security. I think, personally, one of the things the cloud enables is it democratizes the ability for smaller organizations to have the same level of security, networking, and cool stuff that large organizations had. For years, one of the things I always used to laugh about was Microsoft would recommend if you had a cluster that spanned 2 locations, you should actually have a third data center where your quorum drive should live, which we always laughed about because most organizations don't have 2 data centers. In the world of the cloud, it's very easy for you to have 2 data centers or 2 regions or 4 regions, or if you want more regions than that. One of the cool things is that you put compute sources near your customers. If in the past you had customers in Singapore and you wanted to put a CDN next to them, you had to work with a vendor in Singapore. Now you go to the AWS portal or the Azure portal, and you can quickly build those resources. So the cloud gives you a lot of good tools to build really secure environments. It also gives you a sawed-off shotgun that you can shoot yourself in the foot with, that you can blow your leg off with, to quote one of my teammates who always likes to say that. There are some really bad things you can do and you should avoid. We talked about those S3 buckets, but that's just a really basic example. You can put VMs on the internet. You shouldn't, but you can. Denny, my coworker, and I were bored one afternoon at a client office, and we decided we wanted to see how long it would take SQL Server to get hacked if we put it on the internet with an SA password of password. And the answer was about 15 minutes. So in about 15 minutes, obviously we didn't have any data on those servers, but those SQL servers were very quickly breached. So you can do lots of bad things. in all things security and just patterns and practices, you need to understand your risk level and mitigate that risk. So understand the level of risk, understand your risk exposure, and do risk management. And this kind of ties into the site reliability engineering strategy that kind of boosted out of Google. It's acceptable to have downtime, but you want to understand what it is. And then finally, monitoring to ensure your data stays safe is key. So you want to keep monitoring your systems, have endpoint protection, monitor all those things. Let's jump right into patterns and practices, because I think this is the way I did this deck, and I had some help from the UK Cybersecurity Center. They supplied the graphics. There's kind of some patterns and anti-patterns, and we'll talk about them. This anti-pattern is a security one. So this is using an untrusted device to manage a trusted system. And I can speak with experience from working as a contractor at one of the cloud vendors. I can't name who they were, but you can probably guess. When you do administration of a system from a device that's less trusted than the system being administered, only bad things can happen. But this is a very common pattern where you see users who have administrator on their, or admins who have administrator on their workstations because they work in technology that connect to systems that are important. And this can be via SSH, RDP. They're connecting, but these users are connecting to email. They're connecting to the web. They can get phished on these systems. In such scenarios, this end user device can be targeted to be one of the easiest paths into the target system, even if the user's jumping into a bastion host or a jump box. So in computer systems where integrity is really important, and this can be in digital services where you're handling personal data or payments all the way through to industrial control systems. If you don't have confidence in the systems that are being used to administer or operate a system, you can't have confidence in the integrity of that system. There's a kind of common misconception that a jump box is going to inject trust into a platform to somehow make it more secure and remove your device to a device that you don't trust. And unfortunately, that's just not possible. And the way we approach this to make it better is to use administrative machines. And this is one of those places, and I think I said this in the last talk, but security is always a trade-off between being a pain in the I'll be nice and say neck in keeping your systems secure. This is a little bit painful. When I worked at said cloud vendor, the way we logged into production systems in that dedicated machine, we would log into. The only thing that ran on that machine was the instant messaging platform that the vendor used, and it was a stripped-down version of that, and remote desktop or secure shell. Those were the only things we could run on those machines. You couldn't install software. Software could only be installed via a trusted store. And the reason for this is these devices need to be kept hygienic. So they should not natively be able to browse the web or open email, because those are the sources for malware, right? Those are the dangerous things for an administrative device to do. Typically, if you want to do those things from the same physical device, you would create a separate virtual machine that you could boot into in order to do that. But your system access would be just like that. So from there, when we logged into RDP, we then had to multi-factor authenticate using a smart card into another jump host. And there's a rotating password that we didn't know, but since we had multi-factor authentication, you can do that. Now you can use something like a YubiKey instead of using a smart card, supported by more desktops because it works on USB. The idea is that if your machine gets compromised in a virtual environment, it's not the same as that machine that's connecting to the system environment. Not saying everybody has to do this, but especially when you move into larger orgs, this is something that's really important. I will say, though, that if you're a domain administrator or a database administrator and you're logging in directly to your machines as an admin, you should stop doing that as well. You should be using a separate set of credentials for admin activities, which is like the light version of this pattern. And that's just because if your email gets breached and malware gets installed in your machine, you want it to authenticate as a lower, try to move laterally as a lower privilege user, not as your domain administrator account, which can do anything in the domain. So I think that's pretty clear into why you would do this, but that's the way the big guys do it. And I will say Microsoft does a really great document on how to implement this. And in terms of the laptops they use, it goes all the way down to the supply chain is trusted. So they've inspected the factory where those machines are getting built. I think they use Lenovo, but this is, especially in high trust systems, this is a very important approach. But if you learn nothing else from this, take away that your admin credentials should be separate from your regular user credentials. This is another one, control plane bypassing your layered defenses. So when you have layered defenses in a network plane, like a web application firewall, an app server, business logic, and a database, if they can be shortcut via a management plane, those defenses are kind of useless. I'm not even going to say they're my customer, but you can probably figure this out. They have a DMZ. They have a utility host that's kind of acts as a management plane for them. The utility host is this admin server in this picture. It can connect to the web application firewall. It can connect to the business logic. It can connect to the database. So if somebody gains access to that management plane, they have access to all of those systems, and their DMZ is effectively non-existent. So it's really important to kind of understand what your approach to this one is. So if your management server looks like this and can connect to all of those resources that you have out there, if an admin gets breached, you're going to be in a bad situation. And once again, I understand why people set things up like this, right? It's way easier for you to have one box where you can jump on and access all the things you need to access. Maybe you need to deploy code both to the app server and the database server. You need to make changes to the web application firewall. Those are all valid things, but they should either have their jump host or they should be managed individually. And let's talk about the other ways we can remediate that. So build layered defenses into your management plane. So first of all, manage from a trusted device like we talked about, browsing down to those lower layers from separate bastion hosts. So you can have a jump host for each of those, or maybe even have separate credentials, or you can potentially even use just-in-time access to prevent lateral movement. If you're not familiar with just-in-time access, effectively you have a user account. So we'll say Joey at DCAC. I'm owner of our Azure account or a subscription. However, if I log into Azure right now as Joey at DCAC.com, I don't have those permissions because those permissions are managed by privileged account management. In our situation, we just simply have to elevate our permissions. So I can elevate my own permissions without approval, and it goes to a default period of time, and I just document the reason. The good thing about this is, if Joey at DCAC.com is compromised, they're not going to be able to elevate without a lot of manual effort. And even if they did, it would be logged so we could see what happened. Of course, there are other layers there, like multi-factor, that's also preventing that. But it prevents them from simply moving laterally across the environment. The other aspect here is restrict how systems on the data tier talk to the control plane as well. So we talked a lot about data security in the last session. You want to understand, what that data plane looks like and how that works in terms of your databases. There are some organizations I've worked with in the financial services industry where they won't let a single database administrator log on to a box to make a change. They have to have two people logged on at once to make the change, so that there's kind of a trust boundary there, that no single person can do a thing. I mean, I guess two people could work together to steal all the money, but in general, use a layered defense here. So don't have one management host that can get to everything, because you never want to have a single set of keys to the entire kingdom. So this is something I've seen, and I think I've seen this as a regulatory requirement a couple of places. And this is using two firewalls in series from different manufacturers. There seems to be like a widely believed myth that the security benefit of doubling up on firewalls to implement the same set of controls is a good thing to do. Some people also think it's preferable for two firewalls to come from those different manufacturers, because if there's a vulnerability in one, it's unlikely to be present in the other. In my experience, this almost always adds additional cost, complexity, and maintenance overhead for little or no benefit. In almost all cases, you have a OSI layer 3 or 4 firewall. It's got a simple job to do: which network communications can pass through the device and which ones can. Putting two of these firewalls together in series is almost like if you were draining pasta and you drained it using 2 colanders instead of 1. It doesn't actually do anything, but you have to wash twice as many dishes. If there is a vulnerability that could only be exploited in a single firewall, that would be useful. But most firewalls don't have vulnerabilities that can be exploited to yield code execution from a single network packet. They tend to have vulnerabilities in their management interfaces. So this is where you really need to put your efforts. You shouldn't expose those management interfaces to untrusted networks. Even if there were vulnerabilities in the data plane of a firewall, you could swiftly apply patches after their release, which means any attack would need to hit you with a 0-day vulnerability rather than something well-known. So it would have to be a super targeted attack. And also, a better defense in depth design should take more than just a firewall breach to compromise sensitive data or the integrity of critical systems. Having 2 firewalls doubles your admin overhead. You have to deal with 2 different vendors, and you have to retain expertise in both, which adds more cost. Plus, it's 2 firewalls that you have to patch, as opposed to a single set of network infrastructure. I've seen this a number of places, so I think I've heard it being like a regulatory thing, but I don't know who the regulatory driver is for that. So the better approach to doing this is to kind of do it once and do it well. One well-maintained, well-configured firewall or network appliance is way better than 2 poorly configured ones. You want to always avoid exposing the management plane of network appliances to untrusted networks, and properly manage the credentials that are used with them, and have a simple policy configuration that will reduce the chance of mistakes. You want to use good configuration management tools and good source control, so you can easily tell when something's not correct. A telltale sign of a compromise or internal change procedures not being fired, or not being there. But the one exception to this with two firewalls is if you're in a situation with a third party, and we'll talk a little bit more about third parties later and how we manage that. If in that scenario you may have 2 different firewalls back to back because they're communicating between you and a third party, and that's fine, because you're going to have a contract to know what the controls are and know what subnets talk and use multiple pre-shared keys, and that's fine. This is a pretty common thing I see, I think, with a lot of my, I will say, new cloud customers. As they move to the cloud, it's hard, and they're frequently like in a hurry to get there because there's some other challenge. But what I see in some places is They only want to build the solution they have in their own data center. VMware has made a whole business out of doing this. The VMware Cloud is build your exact data center solution in the cloud. And there is definitely a market for that. I think VMware has had some success with it. And there's nothing wrong with using infrastructure as a service because you're going to end up using some infrastructure as a service. However, you really kind of need to understand where you can take advantage of infrastructure as a service solutions, where you can take advantage of platform as a service solutions, especially if you're a smaller organization and you don't have the resources to kind of be constantly patching. Because really the benefit of what you're going to be getting with platform as a service is patching and high availability. So things like database engines, if you can run in a managed database engine and you don't have DBAs, that can be super helpful to you. If file stores, networking is another place. I see a lot of folks that have their own like load balancing infrastructure on-prem, and they want to buy the same one when the cloud native one will work just fine. The other thing too is think about how those resources run, because one of the things about this particular anti-pattern is it tends to be way more expensive than building a cloud optimized solution. People talk about the cost of the cloud and things like that, and sometimes you'll hear people say, "Oh, you'll save so much money going to the cloud, or you'll spend way more." I really think in reality, a well-managed cloud environment is going to cost fairly similar to a well-managed on-prem environment. Storage is typically cheaper in the cloud. Compute is generally more expensive, so that's kind of a wash. You have some network things that you might have had to pay for on-prem that are free in the cloud, but really what you're paying for in the cloud is flexibility. So, for example, if you have development machines that don't need to be running 24/7, don't run them 24/7. Use a serverless model or use automation to shut them down. Don't just stick your entire on-prem infrastructure into the cloud. And the better approach is use these higher order services where you can. Unless you're quicker at testing and deploying OS patches than Microsoft, Google, or Amazon, they're probably better at doing things. I always like to talk, whenever I talk about patching and how the cloud worked and when it, comparing to on-prem solutions. The one that I really like to talk about is when in February of 2018, or January 2018, Intel released, there was an Intel bug, speculative execution, as I recall. I'm forgetting the name of the bug, but this bug was where you could execute code arbitrarily on any server that had, I think, any Xeon processor, if I remember correctly. Or actually, it was any Intel processor back to Pentium. If you manage your own infrastructure, you had to patch the BIOS on your servers. You had to patch your hypervisor, which is VMware, if you're using VMware. And if you're using VMware and you weren't on VMware 6, you had to upgrade to VMware 6 so you could patch that. You then had to patch all of your guest operating systems, and then potentially patch some other software like SQL Server or Oracle had dedicated patches for that. I had customers that were running in Azure at the time, and if you had a VM in Azure, you got an email from Microsoft that said, "Hey, we patched the infrastructure. You have to patch your operating system and your any other subsequent software." So you were still responsible for patching a decent chunk of stuff. Our customers that were on things like Azure SQL Database or Azure Web Applications, they just didn't even get an email. There was no notification. The other thing, too, to keep in mind, and they're starting to implement some of this stuff in virtual machines, but Microsoft has the better ability to patch things online than you do. I wrote in one of my Redmond columns last year, I got to interview one of the architects for the SQL Database platform, and this blew my mind. They have the ability to inject new DLLs into memory on a running database server And they can do this in Azure, I guess, because the environment's so consistent that they basically patch SQL Server without any downtime as it runs in the Azure service. And yeah, you have no way of doing that. Obviously, there are some trade-offs with some of these platform as a service offerings. Sometimes they cost more, and you really want to understand the costing model. That's, to me, where the big decision point lies. But they are infinitely easier to use, and they kind of work to help that. This lets you focus on things that are more important to your organization, and it's easier to keep patched. The other aspect of cloud services is you really don't have to think too much about backups other than understanding what the backup model is. So you need to understand what the backup model is, but you don't need to fret about, are the backups getting taken? Because they're getting taken. That's all I guarantee you the service. So think about this, and I will finish this like pattern and anti-pattern with telling you how it usually works with most of our customers. Well, they initially move in with just the lift and shift mindset, or they'll have a handful of resources where they're like, oh, hey, we can throw this in a database. Instead of using a file server, we'll use file storage. And then gradually, as they get used to using the cloud, there's like kind of I'll say 6 months to 12-month ramp up where they'll start using more kind of cloud native platform as a service offerings. And then usually after that 12 months, they'll start doing their new deployments onto those services rather than just going infrastructure as a service. So keep that in mind. I think frequently for your actual migration, it's fine to do a lift and shift, but you want to think about how you can better leverage the cloud once you get there. So I feel like this was the subject of a major data breach. Like I want to say Equifax was related to something like this. If a third party has completely unlimited access for administrative or operational guidance without any constraints or monitoring in place, this is a really bad idea. Many organizations outsource support to some or all their monitoring to a third party. There are a couple of data breaches, and I know here we're looking at an ERP provider, but if we think about SolarWinds and the way one of the reasons why the SolarWinds breach was so bad was a number of managed service providers use SolarWinds to manage all of the network, like all of their clients' networks. So, right, if I'm a managed service provider X, I might have 100 instances of SolarWinds running against all of my customers' resources, so that I can have, like, in the term of art that I hate because it's overused is single pane of glass. That I have a single pane of glass where my network operations center, I have 3 or 4 engineers that can monitor all of my customers in one place. That's great until SolarWinds, which runs as admin in all of these places, gets breached, and then 100 customers suddenly are breached and affected by the breach. This is really particularly tricky with monitoring software, right? Because monitoring software inherently runs at a really high level. But we had a real similar breach with another MSP software, I think, last year called Kaseya, which is, I think, probably less popular than SolarWinds. But it is something that's a big concern to me about what you let onto your network and things like this. This third-party support isn't a bad thing, but you do need to understand the risk involved. So if you're outsourcing administration or operational functions, you are dependent on another organization to keep your system secure. The staff, the processes, the technology of that organization all need to be considered. Staff and processes aside, if that third party is administering your system, they will require access frequently remotely. Ideally, you'll set up something where they'll come in through a bastion host or VPN, but this is a place where you don't know if they can have trusted machines. We had a customer who suffered a ransomware attack, and it was a result of, it was one of their employees, but they were connected via VPN. And that's something to keep in mind about VPNs. A a lot of times you don't necessarily want to have just somebody connecting over a VPN. You'd rather have them hitting a service endpoint or an API where they're going to have extremely limited access, as opposed to having a VPN. They're on your network. They can talk to anything that is on that network. But let's say you purchase a niche technology that comes with a support contract where the vendor needs remote access to support a specific device. In this case, that organization should only need device or access to the component they're supporting and not any other parts of your system. However, if you granted them, say, VPN access to do that, then they need to have access to your internal, then they do have access to your internal network and all of those things, all of those other additional risks that you have. So this is one of those places where network isolation comes into play. I think it's really something just to have in mind, that as you're working with third-party providers, to understand what that security model looks like. And let's kind of dive into that. You want to have a good contract. You want to have required controls. So if you want to, in my opinion, this is something that's getting a lot better with modern authentication systems. One of the kind of interesting things about Azure Active Directory is there's a really strong business-to-business model. I can be Joey at DCAC if my customers are willing to have it in all of the systems, all of their systems. The benefit of me using that identity is if I were to get fired by DCAC, that customer doesn't have to know that I was fired. DCAC deactivates my account, and it's deactivated everywhere. So having a solution like that is really good. They can also separately force me to MFA. We have MFA in place, but if I'm passing through into a customer system, I have to MFA again, which is a little frustrating at times. But it's something that's important. But you want to have constrained access. You want to have a thorough audit trail so that you can track things. You also want to choose your third parties carefully. You want to get references. And this is something I observe a ton, and this is less so with service providers. I think obviously service providers are important too, but software companies, it's something I run into all the time where, especially in kind of niche software, there's a lot of really bad niche software where somebody had a good business idea, but maybe not the technology skills to build great systems. And I run into a lot of system risk that way, in poor performance and all sorts of various problems, because those systems aren't well engineered. They may have not had, they had business and knowledge area domain expertise, but they didn't have technology expertise. So that's something to be aware of. I always like to tell people to try to get some customer references, even if they're not from if you can find them not from the vendor, that's all the better. And then constrained access. So use the principle of least privileges. Only allow remote and authenticated users to have logical access to the systems they need to reach. Make sure they MFA. If you can, grant access directly to third-party users and don't create identities for them. But like I said, ensure you have the audit trail. And if it comes to incident response, you need to be able to confidently know which commands were executed by which user from the third party. I had to, and it actually ended up being a first-party user, but I had to go down this rabbit hole the other week where somebody dropped a really big table and or deleted all the records in a really big table in a database, and we didn't know how. And I had to go down the rabbit hole. But the key thing was we had the rabbit hole to go down because we had all the audit logs, we had all that information in place where we might not have otherwise had this. And that's super, super important in how you do those kinds of things. This anti-pattern is the unpatchable system. And this is something I like to take back to Comcast because this happened This happened when I was at Comcast. I'll never forget it. We were, the Linux guys were bragging about how they had, and it was actually a Unix system. It wasn't Linux. How they had a system that had been up for like 11 years. And we were like, we kind of laughed and we're like, well, hold on, let's check and let's look in Windows and see what our oldest uptime was. And it turned out there was a Windows server at Comcast that had been up for 13 years. And while uptime is a positive, a server that's missing 13 years of updates is not a good thing. I hope I didn't have to tell you that or explain it to you, but I will anyway. Recently, I had to do a task for a client that required me to be on a physical Windows machine, of which I don't really have one in my house. I have an old Surface Pro 3, which counts that this particular Surface Pro 3 hadn't been booted since October of 2020. I spent the better part of 12 hours, not actively, but it's how long it took, patching the Surface Pro 3 with 2 years of Windows updates. And of course, whenever you're that far behind, when you get updates, they cascade upon each other because they're dependencies. This is not a good situation to be in. But the problem is, and why we have systems that get this way, my Surface was because I was lazy and didn't use it. But in IT organizations, why we have systems that work this way is we have business users or application team leads who are like, oh, my system can't have any downtime. And I specifically at Comcast, I remember the manager who was like that over Spotlight. And fortunately, I had a really nice boss, and we just told them, no, your system's getting patched, and you can deal with it. But you have you get these dependencies, and this kind of just to kind of broadly step back here. If you read Site Reliability Engineering from Google, and it's an O'Reilly book, they talk a lot about outage budgets and systems and how like every system should have a defined outage budget. And this is a good example of that because that manager is like, you can never patch my SQL servers because we can't take any downtime. That just doesn't work because patches are really important. Like this Tuesday's Windows updates were really, when you read the vulnerability list, you're like, these are really, really bad in terms of what the patches are. And it seems it's not every month that they're like that, but it seems like every other month. Another example is the Log4j breach, right? Like there's a big vulnerability in Log4j where you can't, in all sorts of applications, use the Log4j library. It's just a Java logging library. So what do we do to work around this besides having, different organizational philosophies around how we think about patching? The first is, and I know this sounds trivial, is build highly available systems. If you have a system that is so important to the business that, it can barely take any downtime, why is that system a single server? Like, if my business criticality is like that the server has to have 12 nines of uptime, which is, I don't even know what 12 nines is. I think it's, a couple of seconds a year. But our budget was such that we only built a single VM or a single server for it, then that system can't be that important, right? And you want to think about this kind of generally, especially from a patching perspective. In order to have a highly available system, you need at least two instances of that system, no matter what it is. And I'm kind of thinking in my head about databases, but you can also think of web servers or anything else. Because when you're patching an operating system, it's probably going to take the operating system down for a couple of minutes at a time as you do that. Like, there's no inherent way around that. And that applies, I don't care if you're using Linux, Windows, a Mac, whatever. When you patch an operating system, it takes time. So if you want to be highly available, you have to have 2, or in some cases 3, or in some cases 6. I've seen crazy things in the world. Your systems have to be able, your applications have to be able to be tolerant of these faults. So like your application can't freak out because the database server went away for 2 seconds to fail over while you're patching the normal primary node. If you want that level of availability, and this is where like kind of as an architect or an admin, you have to work with the business to have an understanding that if they want this level of uptime, they need to make investments into their hardware and infrastructure, because otherwise they're just not going to get that level of uptime. By designing highly available systems, you do reduce the risk of outages. One of the kind of cool benefits of the cloud is, especially for customers that don't have really robust infrastructure, I think it's a lot more natural. The SLA levels in the cloud for just their baseline uptime are much higher than you would get on-prem. I think the baseline uptime for an Azure or AWS VM is 99.9, which isn't terrific, but it's better than if you have like unreliable hardware. Patching more frequently reduces the risk of compromised systems. It also reduces the risk of. It also reduces the amount of time that you need to patch. Like I mentioned, I spent 12 hours the other night patching my Surface. Normally, and I have a Windows VM on my Mac that I normally use, and I patch it all the time, and it's usually just a few minutes. But I patch it when Windows tells me to patch it, not a year later. So this is something you really need to stay on top of, especially if you have a lot of VMs in your environment and kind of a more traditional environments. I always like to say that security is hard, but data breaches are harder. Anything you do to add security to a system makes it harder to use. Multi-factor authentication is kind of a pain. Like, I have to multi-factor authenticate. I use an iPhone, so I have to get Face ID, so I have to have the phone at the... And Apple's pretty good, but you still have to get the phone at the right angle. Then I might have to do it again, depending on what I'm logging into. However, I'd much rather have to do that than have to write an email to all my customers saying their data got breached, or work with the EU Commission for GDPR fines. Good security means securing all of your systems, including the management plane. I know we made the point about using secured admin computers, and that is, I think it's a little bit extreme. I don't think it's crazy, but there are more companies than you think of that do that. And it's a really good approach because it really locks down lateral movement. When we think about these like modern attacks, the way they almost all work universally is that it's they get in, they try to capture admin credentials from somewhere, and they capture those admin credentials and they move laterally, and then that's how most ransomware attacks work. So if you can limit the scope of the credentials that are available, you're only using admin credentials on admin systems. You have MFA, and even better hardware MFA. One of the things that came out in the breach last month, that breach with like the 16-year-old British kids who were hacking stuff, they were getting MFA. They were basically spamming people with MFA requests in the hope that they would get one. So like they'd spam all the admins on a team with like thousands of requests, and it only took them getting one session. And that's where that was actually what drove me to start using a YubiKey, because if you have hardware-based MFA, that can't be phished. Like they can't get in with a remote session that way. So keep all of those things in mind. And I know it's like a lot to worry about because the world is a dangerous place. Limit your access to third-party vendors. I wouldn't just say limit. I would say understand your access and understand their access. Make sure they only have the access they need. Make sure they're audited the same way your own employees are, if not a little more. And then patch your systems. So 13 years is a bit extreme. Even 2 years for my Surface is a bit extreme. We have some customers that do this quarterly, which to me, I'd feel more comfortable with a monthly cadence. But have a test environment. In a cloud world, it's easier to have test environments. And and keep that in mind. You don't want to have the 13-year uptime systems. That is not a record I want you to shoot for after this session. With that, thanks everyone, and let's kind of dive into the Q&A. I see we have some good questions there, John.
Sure. Wow, 13 years, that is amazing. Okay, I just want to remind everybody that you can enter your questions into the Q&A box at any time. There's still time. We've got 15 minutes for questions here. Let's get with Tina has got a pretty good question here. She says, applications get elevated access to be able to function. Does this present control issues?
It does. Impersonating an application is a really good way to attack a system. And one of the things that I read an article for Redmond a couple of years ago on like the worst 9 data things I've seen, and one of them is running SQL Server as a service account as a domain admin, because then anything you do from SQL Server is now domain admin. It's something you really want to be conscious of, and in a cloud world, we have a lot more application identities, I think. We have a lot more tools for being granular, but you want to use the principles of least privileges for your applications, just like your users, and in fact, more, because I think that in some ways the access can be a little bit more unconstrained.
Okay, so Russell is looking for some clarification here. He says, so you are suggesting that it is preferred to use local accounts and passwords to separate devices versus using AD groups and credentials?
Absolutely not. It's funny he asked that question, because this morning I was working on a client system, and it was in their DMZ, and they don't have a domain controller, and I was having to do everything locally. No, AD off is almost always going to be better, because you kind of have some more control around things like lockout and policy inconsistency. AD is a little scary, because like Kerberos has been breached in places. What I was really saying there is you should have. I'm sorry, I drifted out of what he was actually asking. What you should have is an AD account for. Was it Jonathan who asked that question? I think you should have like Jonathan user at Contoso.com. Contoso is Microsoft's fake company. And then you should have Jonathan admin at Microsoft.com. And you only use Jonathan admin to do administrative stuff. Like you do your email and you do your all the regular stuff you do in your desktop as Jonathan user, and then Jonathan admin is the rest of the stuff.
It was, just to be clear, it was Russell. And we do have a question from Jonathan, though. He's wondering, is there a good way to implement hardware-based MFA for, say, access to remote desktop protocol?
Everybody's asking me questions today that came up at work this morning. This is really kind of good. Actually, I think this came up, to be fair, this came up yesterday. There's nothing good native in Microsoft land that allows you to use hardware-based MFA. I can say at Microsoft, at Cloud Vendor, what they do is you have a trusted workstation, and you could use a smart card to log in. And I think that's done through ADFS. I don't think that's like part of just native AD domain services. This is a place where third parties mostly come in, like Okta, Duo, those folks. I think they all support that. And so that would be the approach I take. ADFS has a bunch of like kind of inherent risk with it, so I'd look to the third parties, but it's probably a valid discussion to have with your team from Microsoft as well.
Okay, Tina's got another clarifying question here. She's wondering, granting access concerns me. Don't we want to know individual access for audit/control purposes?
Yeah, even if you're kind of granting access broadly, and so if you're granting access to third-party identities, you're still going to have their individual access logs. They're logged in. And I'm kind of speaking specifically to Azure right now, but those things are logged in your tenant, just as if it was one of your users. The users look a little bit different, but they're still pretty clearly, and that's just kind of the internals of how the authentication happens. But they're authorized the same way and they're logged the same way. There's really no difference. Where this becomes a little bit troublesome is as you move away from like Active Directory and into, or excuse me, Azure Active Directory and into kind of traditional Active Directory, the only way you could like have third parties would be to do like domain trust, which is where, let's say, DCAC merged with JDA, which is my company. We would trust our two domains together, and Joey at joeyDantoni.com could then authenticate into DCAC.com. And effectively, it becomes one forest is the term. But we still have kind of full logging and auditing in the environment. So yeah, it's more, you kind of just want to ensure you know what machines they're coming from and things like that.
Okay, we've got a question here from Vic, who's wondering, speaking of all this, your patching efforts, how do you go about making systems easier to patch? Is it possible to do that?
I don't really think it is. I had some people you can email on the Windows team. I think, honestly, I will give Microsoft some credit here. If you're running at Windows Server VMs in Azure and you're running Windows Server 2022 and you stand on two toes and cross your fingers, it's not that bad. There's a way to do hot patching with Windows Server 2022 now. It's only supported in Azure, but they are making progress on that. But in general, no, patching is kind of pain. Like, I use a Mac. I don't have anything against Windows. I just kind of got in the habit of using a Mac, and it's always painful. It's always painful to patch. So, yeah, it just kind of sucks. I would say build more highly available systems so you don't have to worry about patching more than worry about patching. But if you're on Windows and you're in Azure, look at the hot patching things. I think that's pretty cool.
Okay, Michael has just asked a question here. He's wondering, what are your thoughts on geolocation?
I'm not sure what he means by that, but I wonder if he means based authentication. I mean, we have our authentication configured that way. So, like one of the risk patterns in Azure Active Directory is unnatural travel, which because of the way we're set up, we've done a lot. Or like I'm sitting in Singapore and I VPN to a server in LA. Yeah, so IP geolocation is not perfect, but it's good enough for things like that, where you're not locking somebody out, but you're adding an additional level of control, and you can kind of add that risk-based authentication into that model, and it's a good approach.
Okay, let's see here. Tori is wondering, what are some of the worst practices you've observed? And just to be clear, Michael is clarifying that, yes, along the lines of login. So,
yeah,
that last question. Sorry, Timmy.
No problem. I've seen some stuff. It's typically like unconstrained network access or unencrypted data that the entire company can get to if they know where to look at all. Yeah, I think people are getting smarter because the risk of attacks is so much higher. Honestly, the thing that scares me the most when I see customers kind of nowadays is running on like 10 and 12-year-old software. That's like, even if it's patched, they're not like Microsoft, Red Hat, whoever. They're not, or VMware. They're not updating those systems, right? So they're like inherently vulnerable, and that scares me. So if you have a lot of like legacy systems, do what you can to get those things isolated into maybe their own subnets too. Like, because I know in an organization of any size, you're gonna have some of those systems like, and I talked about third-party vendor software sucking. This is a common trait of that. Like, we only support Windows Server 2012 forever, right? And even though it would probably run fine on 2022. So if you're in that situation, that's when you want to take advantage of tools like isolating things, just to limit the exposure.
Okay. Here's one. This is kind of a huge question. How does a secure access workstation work? Yikes! Is that something you can actually?
It's pretty basic. It's like the crappiest machine you've ever had. Like it just runs RDP and maybe a chat. So no email. And chat, the place we were, chat was super locked down. So you couldn't paste attachments in the chat. It was only text. And then you RDP'd. It had a slot for a smart card. And when you RDP'd, you had to enter the PIN on your smart card. That would pass through to like another jump host. Basically, it's really hard to do anything because you can't cut and paste, you can't access resources. So it's really hard to do anything. And this is where having things like DevOps pipelines to deploy code and things like that are really good.
Okay, we got.
Yeah, let me just wrap up. There's kind of a modern notion that, and it's accurate, that you should really never be logging into a production system. You should only be troubleshooting from logs and making configuration changes that pass through source control. And I think that's kind of the notion of a secure workstation, is that you should never be having to log on to one of those boxes to run code.
So Michael was just observing that Windows 11 now has kiosk mode.
Oh, that's interesting. Yeah. Cool. Well, that was a lot of good questions.
Maybe wrap up with this last one. That's kind of, do we really have to do all this stuff?
Man, it's a scary world out there. Like, we haven't had a ton of clients that we've dealt with ransomware, but there's a steady cadence of it. And you don't have to do all of this stuff, but doing a lot of it will really lock down your environment and reduce your risk. We're pretty heavily involved with Microsoft, and I've been doing a lot of the security improvements that they recommend. And honestly, and they're both in on-prem and Azure. For the most part, I don't think anybody's complained or even really noticed. And our security score is up to about 90, so I'm pretty comfortable with that. But yeah, it helps to have a metric or an audit to kind of guide you by, so that you have something to score against and a goal, and not just arbitrarily trying to fix things.
Looks like that's all our questions, so we'll go ahead and wrap it up. Thanks, Joey, for an awesome session. Actually, 2 sessions. Did double duty today.
Yeah, for sure.
So maybe thanks to Joey D'Antoni, who is the principal consultant at Denny, Cherry & Associates Consulting, for 2 absolutely awesome sessions. And extra thanks to Rubrik, the Zero Trust data management company, for making this summit possible. Now I'm going to hand you off to my colleague, Victoria Wava, project coordinator in the Client Services Group of 1105 Media, who will provide some closing announcements, including the name of the winner of that awesome Rad Mission 1 electric hybrid bike. Victoria?
Thank you so much, John. Hi, everyone. My name is Victoria Waba, and I just want to thank you all for joining us today. Just a few closing announcements before we depart today. As you leave, you will be asked to take a short survey with your opinions of the event. Please share those honest opinions. Our editors read every comment, and they help to shape our future events here. And speaking of future events, we really do want to thank Rubrik. They're sponsoring this event because they believe in this community and want to support events like these. So please show your support and appreciation by downloading their resources and visiting their site and contacting them for a demo. It's through their underwriting of these events that we can bring more summits in the future. Rubrik has also provided a link to a demo in your audience console. It should be to the right of your console, so please take a moment to check that out. So thank you, Rubrik. Thank you to our speakers. Thank you, fellow moderators. And now let's draw the winner of our random prize drawing. Congratulations, Jack User from Horizon Personnel. You have won the Rad Mission 1 electric hybrid bike. Our team will be in touch with you on how to claim your prize. That's it for today's summit. Thank you all so much. Just a reminder, you will get a replay email in the next few days with the full recording of the summit. We do hope you enjoy this event, and please do take that survey that pops up when you exit. Thank you, and thanks again to Rubrik. Have a wonderful rest of your day, everyone.